Welcome back to FPV Reviews. Today we'll be building the center wing section for Gemini V-2 using the high-quality laser cut kit from Flying Squirrel Models. So let's get started by locating parts number 7, 2 of them, parts number 9, 2 of them, parts number 10, 2 of them, and a section of half-inch square basswood stock supplied with the kit. Mark and cut the basswood to length using one of the number 9 or number 10 pieces as a guide to measure it. Cut 2 pieces of the basswood to this length. Glue the number 10s together with the basswood stock in the middle, and do the same with the number 9s to make the cross members. Align them carefully and make sure plenty of glue is used, as these are critical joints. Locate parts number 11, 2 of them, and glue them onto the parts number 7, being careful to make a right and a left side mirror images of each other. Snap the assemblies together, making sure that the front crossmember is the taller, made from parts number 9, and the rear is the shorter assembly made from parts number 10. Tack the assembly together on a flat surface. When dry, lift it up and glue all of the joint areas inside and outside of the ribs. We'll need to have the full-size plans printed and lay them on a flat surface, placing a sheet of clear plastic on top to prevent the glue from sticking. We'll also need to have some other parts on hand. 4 7 by 1.2 millimeter carbon fiber strips, 1 meter long, 1 23 by 25 by 1 meter long carbon crossweave tube, preferably with a matte finish, 3 1/4 inch by 3/8 inch balsa strips at least 2 feet in length, 5 1/4 inch square balsa strips of the same length, parts number 8, ribs, and parts number 19, the nacelles. As you'll notice on the plans, there are 2 options for the nacelles, but today we'll be building the box-style nacelles. They're the more complex of the two, and most people prefer them. Parts for this type and for the profile-style nacelles are both provided in the kit. We'll take a minute to glue 4 ribs, part number 8, to the nacelles, 1 to each nacelle part, 2 on the left side of the nacelles, and 2 on the right side. Take 1 of each type and make a relief for the trailing edge stock. These will be the inboard sides of the box-style nacelles. This can be done with a hobby saw or a hacksaw. Some of the latest versions of the kit have an extra set of number 8 ribs. If so, glue them to the other side of each inside nacelle in the same way as the others. That's the ones we notched for the trailing edge. If your kit does not have the 2 extra ribs, just leave them out, as they are not absolutely necessary. Now let's start sliding the parts onto the carbon tube, starting with the center assembly and the remaining number 8 ribs that are not glued to the nacelle sides. Do not glue anything to the carbon tube. Now push the balsa strip stock into the ribs, but only on the top. We can ignore the bottom pieces for right now. Next, take the inner nacelle parts that we made the cutouts to for the trailing edge and slide them into place from the side so that they end up with the ribs that are glued to them on the inboard side. It's not absolutely necessary, but it's helpful to make 2 spacer blocks, 12 inches long and 2 inches wide. In this case, we made them by gluing a piece of 1x2 pine from the hardware store to a piece of the half-inch square basswood. We now will use 2 clamps to hold each spacer between the sides of each nacelle temporarily. This is the time to get everything aligned over the plans. It's perfectly okay to let the balsa stock protrude past the nacelles for now, as it can easily be trimmed later. Set up a square on each end of the wing to ensure that the nacelles are perfectly upright. Once we're satisfied that the spacing and alignment of the parts is even over the plans and perfectly square, we can tack glue the intersections of the balsa strips and all of the ribs, including the nacelles. After the glue is dry, the spacer blocks can be removed. It's now possible to tack glue in between the nacelles as well. Once the glue is dry, we can lift the structure carefully and turn it upside down. Now we can slip in the bottom spars and the leading edge. We'll tack glue them into place too. Next, we can slip the top carbon strips into place and trim them to length. We can glue them in place using thin CA to penetrate the joint, or lift the strips and use medium CA underneath them. The carbon strips on the bottom of the wing are much easier to glue into place. They can even be glued into place and trimmed later using a hobby saw or Dremel with cut-off wheel. We can now remove the carbon tube and lay the assembly back on the bench right side up. We'll now take a piece of 1 1/4 inch trailing edge stock, cut it to length, and mark it where it will be notched for the ribs and nacelles. This can easily be done using the hobby saw over the edge of the workbench to make the cuts and a number 11 X-Acto blade to remove the pieces. Now we can trim the excess from the longitudinal strips, making flush cuts with the hobby saw. We'll now use 1/16 inch thick by 4 inch wide balsa sheets to form a D-tube structure on the wing's leading edge. First lay the sheets along the leading edge stock and mark the length. Cut to length, then put back in place to mark the width at both ends. Cut both length and width using a straight edge and a hobby knife. Apply glue to the edge of the sheet and glue it to the leading edge stock of the wing. Once the glue is dry, apply more glue to the structure underneath and hold the sheet down until it's dry. Repeat this process for all sections of the D-tube. Check to make sure that the wing is not warped. It should be straight, but if there is any warping, it can be corrected by holding an opposite warp while applying the webbing in between the spars later on. We'll cut some strips of 1/16 inch balsa to 2 inches wide with the grain running crosswise. Glue these strips in between the nacelles on top of the ribs, gluing them into place preferably on the structure before they are put into place, or afterwards from underneath. Continue all the way to the trailing edge and trim off the excess. Cut and glue a piece of 1/16 inch sheet between the center ribs and the spars on the bottom of the wing only. This piece and the next 4 similar to it should be cut to fit between the ribs, not on top of them. Trim the back of the last sheets as shown to make sure that the covering will lie smoothly over the top. These pieces give the covering material something to stick to later on. Use 4 1/4 inch dowels or similar material, inserting them into the outside nacelles to make alignment dowels, gluing them from the inside. We'll now locate parts number 22, 2 of them, parts number 21L, 2 of them, number 21R, 2 of them, number 23, 2 of them, and number 24, 2 of them. It will also be useful to have our motors at this point, as we'll be using some of the hardware provided with them. In this case, we're using E-flite Power 25 motors. Inside the hardware pack, we'll find 4 blind nuts per motor. The barbs line up perfectly with the slots in parts number 23. Set them exactly in place by hand, then gently use a hammer to tap them firmly down flat. Apply glue all around each one, being careful not to get any inside the threads. Now apply glue to one side of number 21R and number 21L, one at a time and glue them to the inside of the nacelles, being careful to align the top and front edges perfectly and without getting too much glue in the notches. Now apply glue to the outer side edges of part number 23. It will go into place with the flat edge up and the blind nuts on the back side. Spread the nacelle sides slightly to insert it, and then squeeze them together to snap it into place, doing so quickly before the glue dries. Now place a small amount of glue on the back side of part number 24 and glue it to part number 23, holding it in place with clamps until the glue dries. Now apply glue around the top edges and insert part number 22, holding it into place until the glue dries. We can now test fit the motors using the supplied hardware, but we'll want to remove them later when we paint the nacelles. Now is the time to install the speed controllers, or ESCs, in this case Castle 50 amp edge or above. Feed their wires down through the slot on the inboard nacelle. Holding them in about this position, use a 1/8 inch drill bit to drill through the thin balsa sheeting where the mounting tabs are on the speed controller. Once the holes are drilled, make a backing block from a piece of scrap 1/8 inch plywood left over from the kit and glue it in place over the holes from underneath. Once the glue is dry, use a smaller bit such as a 5/64 inch bit to drill through the same holes from the top and through the backing block. Now is the time to solder the female bullet connectors that came with the motor onto the 3 wires that came from the speed controller. Apply heat shrink to them so that they will not short out later. Best to leave the 3 ESC leads and the motor leads full length, as this will let us plug them in and swap leads to customize the direction of rotation later on. The loose leads are easy to secure once the airplane is complete. Set aside the motors and speed controllers for now. Use the remaining 1/16 inch balsa sheet to cut cross-grain webbing and glue into place across the forward side of the rear spar and the rear side of the forward spar. Locate parts number 16, 4 of them, and glue into place flush with the surface, on the bottom of the structure in these locations. These plates will accept the screws from the wing retainer plates later on. You can now use a sanding block to make a fair, rounded leading edge on the front of the wing. We can now fit the wing center section to the fuselage. We'll want to make sure that it is sitting flat on the fuselage and that the cross members in the wing line up directly above the ones in the fuselage. It will most likely be necessary to trim the forward fuselage sheeting slightly to achieve this, so mark the location with a straight edge and use a hobby saw or Dremel tool with cutoff wheel to make the cut. It's optional, but if you have a piece of 3/8 inch triangle stock balsa, glue that into place behind the ledge to take up the space there. Once you're satisfied that the wing center section is centered, square to the fuselage, and the cross members are lined up, use a drill bit inserted in the pre-drilled holes in the fuselage cross members to mark the locations for holes in the wing cross members. This marking can be done by hand, as we only need to mark it, not drill it yet, and it's difficult to fit a drill inside the fuselage. Remove the center wing section and drill the holes out with an actual drill from the bottom using a 9/64 inch drill bit. We'll now be installing the 2 832 by 2 1/4 inch machine screws with nylock nuts and flat washers. To insert them, we'll need to make a relief hole in the D-tube sheeting above the forward cross member. This can be done with a number 11 X-Acto blade. The screws can now be inserted from the top with a washer under each head and the heads glued into place as studs in the center wing section. Place the wing section back onto the fuselage and verify the fit of the bolts. Drill out the holes in the fuselage crossmembers slightly if necessary. From inside the fuselage, mark the wiring relief holes onto the center wing section bottom sheeting with a pin or pencil. Now take the wing off again and use the number 11 X-Acto blade to make the cuts. We'll be using masking tape and paper towels to cover the parts of the wing that we don't want to paint. Apply automotive primer, in this case Krylon Rust Tough Enamel Primer, to the nacelles. When dry, give a light sanding with 220 grit sandpaper, and then coat with your color of choice, in this case Krylon Gloss Black Enamel. Once the paint is completely dry, use 100 grit sandpaper to remove the paint, only from the top edges of the nacelle sides. Now install the speed controllers, taking care to mask the wires to the motors, but making sure that the towel can be released later with a gentle tug. We'll use some scraps of 1/8 inch ply from the fuselage kit, mark and cut it into strips 2 1/4 inch wide, and glue these to the top of the nacelles. Use a sanding block to fair the edges and the joint between them, and then use the primer to seal it. After the primer is dry, give it a quick sanding and the final coat of paint. When the paint is completely dry, remove the masking tape and mount the motors permanently this time. Place a towel on the bench so as not to scratch your fresh paint, and turn the center wing section over, upside down. Use number 10 gauge silicone wire to create a wiring harness in a Y configuration for the power wires, using an XT90 connector for the battery. Do the same with the speed controller signal wires, eliminating both red wires so that there is no conflict between them, as they will both be trying to supply power from their internal BEC. Best to use neither of their BECs, as an ESC failure would cause a loss of power to the servos for the flight control surfaces. Also make an additional standard Y harness for the aileron servos, which will be in the outer wing sections, leaving a servo connector for each side with some slack for assembly in the field. The wiring can be glued to the wood structure to keep it in place and out of the way of the main carbon tube spar. Congratulations, you've now completed the center wing section for your Gemini V-2 and are one major step closer to getting it in the air. Plans and kits are available at the links below, along with lots more information about the Gemini V-2 UAV and our other advanced projects. Don't forget to subscribe and hit that bell icon for notifications. We've also got some exciting flights planned as soon as the weather improves, so stay tuned for that as well. Until next time, have a good one.